We're going to look at parent functions and quick graphs, but we're going to do it the not quick way because we want to find out why an actual movement's happening a certain direction. There's another video that shows quick graphs somewhere on here. Okay, so we're going to make a table of values for all of these. Now, all of these are going to give us a parabola. We're going to plug numbers in and we're going to solve. We're going to figure out why a graph moves a certain way. So, starting off with f of x equals x squared. Now, it says f of x, pretend that says y. They mean the same thing in the end, but you see f of x, don't get scared, pretend it says y. Basically, all we're doing is plugging these numbers in for here. So -2 times -2 gives you +4. -1 times -1 gives you +1. 0 times 0, 1 times 1, and 2 times 2 gives you 4. So what we just found is your basic parent function. Every graph that's on here, all of these are going to stem from what we do right here. So back 2 up 4, back 1 up 1. That is our basic parent function. Now we're going to find out all of our movements and every little detail that happens from here. All right, let's say we've got a negative out in front. That negative is going to flip our graph upside down. Let's see how that comes about. So we need to follow order of operations here. I've got two things going on. I've got an exponent and multiplication times that negative. I need to take care of the exponent first. So I'm going to say -2 times -2, which gives us a 4. But then I multiply it by that negative, which gives us a -4. -1 times -1 gives us +1, but times that negative, -1. And then all of a sudden, we kind of turn this whole problem into negatives, all of our answers. So back 2, down 4. Now, if you notice, we still start off at 0, 0, but our graph happens to flip over that x-axis, okay? What happens now if we plug in +1 at the very, very end? Let's plug the numbers in. So again, order of operations, exponent first, then we're going to add. So -2 times -2 is going to give us 4. 4 plus 1 gives us 5. -1 gives you +1 plus 1, 2. 0 times 0 gives you 0 plus 1 is 1. 1 times 1, 1 plus 1, 2, and then 5. So remember, when we're dealing with parabolas, once you find that vertex, things start to repeat themselves. If we plot back 2 up 5, back 1 up 2, over 0 up 1, our graph now happened to shift up. Interesting. So if you've got x squared and then you get that +1, or you have plus or minus, something's going to happen. It's going to move up or down. In this case, it moves up. If I've got a -2, the whole graph has to shift down. So rather than making this whole table of values again, I'm just going to shift my parent function down 2 spots. So we go down 2, go up and over, and then I think we're there. So just to understand, whenever you have a negative, we flip. When you have a +1, we shift the graph up. When you have a -2, we shift the graph down. Okay, what about if we've got parentheses and a number inside those parentheses? Well, order of operations, always start with inside the parentheses and then take care of the exponents. So, and if you notice, I started off a little different than the other ones just because our graph is going to be a little off-centered. So plug 0 in. 0 minus 2 gives you -2. -2 squared gives you +4. 1 minus 2 gives you -1. -1 squared gives you 1. 2 minus 2 gives you 0. 0 squared is 0. Plug 3 in. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared gives us 4. So we have our repeating numbers. Go over 0, go up 4, go over 1, 1, 2, 0. And now our parabola happened to kind of shift to the right. When you have a negative, we shift to the right, okay? Interesting. We kind of went in opposite directions. So without making this table, let's go with the rules. If we know a +1 goes up, a -2 goes down, okay, they move opposite directions. A negative moves right, but then a positive must move left. And in this case, it moves left 3 spots from the parent function. So there's your origin. And there you go. Our graph shifts to the left when you've got a positive. What about if you have a number in front? So this is going to do something a little different. This is going to take our parabola and it's going to make it either really, really wide or really, really skinny and thin. So how does it happen? I don't know. Let's plug the numbers in and see where it goes. So -2. Again, order of operations. Exponents first, then the multiplication. So -2 times -2, +4, times 2 gives you +8. -1 times -1 gives you +1, times 2 gives you 2. 0 squared, 0 and 0 gives you 0, times 2, still 0. 1 squared, 1 times 1 is 1, 1 times 2 is 2. 2 squared is 4, 4 times 2 is 8. Okay, go back to up 8, go back 1, up 2, 0, 0. All of a sudden, our graph kind of got skinny. All right, so if you have a number that's bigger than 1, your graph gets skinnier. So if I said 5x squared, I'm going to have a graph that's even going to be skinnier on the inside of that. Now let's see what happens when you have a fraction. So -2, again, exponents then multiplication. -2 times -2 gives you +4. What is half of 4? 2. -1 times -1 is 1. What is half of 1? 1/2. 0 squared, 0 times 0 is 0. 0 times a fraction, still 0. Plug 1 in. 1 times 1 is 1. Half of 1 is 1/2. And then 2 squared, 2 times 2 is 4. Half of 4 gives you 2, okay? So back to up 2, back 1 up a half. So we're kind of between the 0 and this 1 here. 0, 0, 1.5, 2, and 2. So our graph now kind of gets a little wider. If you happen to say 1 over 10, 1/10, that's going to get even wider and going to get flatter and flatter and flatter. So this is a detailed version of parent functions and finding the movements of the quick graphs. So this was thin, this was wide. So that's finding parent functions and quick graphs with quadratics.